All right, today we're going to talk about how to solve palindrome number. Given integer x, return true if x is a palindrome integer. Integer is a palindrome when it reads the same backward as forward, which means basically if you reverse it and it's still going to be the same thing. In example 1, if the input is 1 to 1 and the output is going to be true, because if you flip it like 1 to 1, it's going to be 1 to 1 again. And in second example, we have 1 to 1 again, except it's negative, and it's going to be false. So negative numbers in this case are always going to be false. And you can see once we reverse it here, we have the negative sign on the right side, and we don't really want that. And if you keep looking down below, we have a follow-up. Could you solve it without converting the integer to a string? Which means we can't take this entire number 1 to 1 and convert it into a string or use any string built-in functions. Yeah, of course, if you know, if you're familiar with like pointers with like string, it will be much easier because we could set like 2 pointers, one at the beginning and another one at the end, and we could just compare each character, and if they equal, we continue. If they not, and we could just return false. But that's not the case. And today we're gonna solve this problem by using like math operations on the input integer. Here I can make some space, and I'm gonna show my demo here. So suppose we have a value 1, 2, 3, and the x is 1, 2, 3. Sorry for the handwriting. And here's the concept: like, we want to get the digits in the ones place of the input x and store it as the most left digit. This one is the most right digit, right? I want to store it as the most left digit of another variable. And in this case, we know that the digit, like the leftmost digit, is going to be in the 100 place, right? The digit in the 100 place. So I said we have a reverse variable. So digit will become the leftmost value of the variable is going to be here. And since x has 3 units, right? 1, 2, 3. And we want to get the digits like we're gonna add 2 more numbers to the reverse variable. So when the 2 slots are filled, then we compare x with the reverse variable at the end to see if the input number is a palindrome. And so that's the general idea, like how to solve this problem. But how can we get the like the ones place at the very beginning, or the rightmost value in like math? We can mod the input x by 10, right? That's the solution. We could use a mod operator, and we can mod it by 10. So if we take 1, 2, 3, mod it by 10, we get the value 3 here. And next, we want to save it to the variable. We already did it earlier. So now here's 3. And since we already got the most right value for the reverse variable, we can just get rid of 3 right now, like by chopping the tens of the input x. But here's the thing: we can take x divided by 10, right? But remember, we need to compare x to reverse variable at the end. We talk about it. We want to compare these two. And so it's better to create another variable, and we can call it like copy. And we set it to x equal to x. So what it does is we're going to use copy variable to hold the value of x. From now on, and we're going to only operate on or like alternate the copy to get a value for the reverse variable. And again, if we divide the copy by 10, so now copy has the same value, like 1, 2, 3. If you divide copy by 10, and we will chop off the ones place, and it will round down, and then we will get like a value of 12. Let's say 1, 2, 3, we divide by 10. And so now we are left with 12, right? In order to get the next value for the reverse variable, we are basically going to repeat the process until the copy is not equal to 0. So we could just, after we get 3 here, and we could just get rid of 3, and we have 12, and we could just get rid of 2. We add 2 to here, and then the last one, we could just get rid of 1, and we add 1 to the reverse. Okay, so I hope this is helpful, because this is a math, and we're going to be doing, and the rest of the problem becomes pretty simple once you can just figure this out. And I know this might be a little confusing right now, but as we go through the code, you will understand how the idea works. So let's jump into the code. Let me just undo everything here. Oh, okay, let's go. All right, so now we have a function here. Okay, here we have this palindrome function, and we are given an input value x. And first up, we need a if condition to check if the value is negative or not. And if it's negative, we're gonna just return false, right? And that's gonna be our first edge case. So any negative numbers are always going to be false, okay? And next we're gonna do is to create a variable called reverse. And later we're gonna use this to compare with the input x. And we set it to 0. And then we gonna have a copy, make a copy of the input x, the value of the input x. So, well, x is a non-zero, and that means we're going to continue to repeat the math operations on the copy variable, right? So we're gonna do, as long as copy is not equal to 0, and we're gonna do whatever we're gonna to be done inside the while loop. Well, let me see. So inside a while loop, we're gonna grab the last digit, right? We could just call it last remainder. And to get the digit, all we need to do just to mod it by 10. So we could do copy 10. Once we have that, then we're ready to roll with the rest of the algorithm, right? So now we have the last digit. It's time to update the copy variable by getting rid of its most right digit, which is, if we remember earlier, if the input is 1, 2, 3, we need to get rid of 3. Then we can just say copy equal to copy divided by 10. And so we are just chopping off like just the last number, the digit. And now we can just say reverse is equal to reverse times 10 plus remainder. Okay, so now basically we're gonna take x and compare it to its reverse version. So we can just return x double equal reverse. Then we check if they equal to each other. And if it does, then we could just return true. Otherwise, we're going to return false. And let me run the code. Oops. Return outside the function. Oh. Here. Submit it. So the time complexity of our solution is going to be big O of n. And then our space, since we only have one while loop, and our space complexity is going to also, it's going to be like big O log 1. All right, thank you for watching.